I'm Darcy, and today I'm just going to kind of do a recap of the things that I've learned about what's happening to the geography at Lynn Valley. So I kind of divided it based off of like what was interesting to me and how I connected everything I learned from what we observed. So really quickly, here's my kind of drawing of the water basin. That encapsulates Lynn Creek where we had our field trip. I've never drawn one of these, so I don't know how accurate it is, but what I did is I found like the topographic high points and connected those to kind of understand how the creek flows all the way down into the outlet, which is Burrard Inlet. So yeah, this is my little drawing. The first thing that was really evident to me were how big the rocks were. Everywhere we went, it was very prominent that the rocks were um, they were very big. Um, so this kind of defines the bed load of the creek. It's defined by these larger clasts. And this would mean that if transportation were to happen, it would happen with more of traction, like the sliding motion, or saltation, like the bouncing motion. And this would happen if the water was really fast and had a high velocity. And if the rocks were kind of loosened from the bottom of the creek. This could allow the movement to happen, um, which is why we didn't see suspended sediment. We didn't see suspended sediment because we have so many large boulders here that are left behind, whereas the smaller clasts like sand or gravel or any of the other sediments, they would have already been carried down to Burrard Inlet. So what we're left here are these larger rocks. So that's what I was seeing was the larger rocks that were left behind. Whereas everything else that's smaller has been carried down stream already. So if you can see where I'm standing here, you can see those smaller bits of sand and gravel and rocks. Those haven't been washed away because the river, hasn't reached where my feet were. So that's just a little interesting thing that why the water runs super clear, looks super drinkable, and has left behind all of these larger boulders without those smaller clasts. Another thing that was really apparent was how much granite there was everywhere. So the first thing the first time I noticed this was when we were on the pipeline bridge and we were looking down. There was just granite everywhere and big granite. Again, not those not smaller rocks, but huge. This is bedrock and it's large boulders. Um, and so I was able to tell immediately that it's granite because growing up on the West Coast, I feel like you see granite everywhere. You see it all the time. You just know that it's granite. It's got a very distinct speckled look. Um, so that really became evident was how big the granite was and how the bed load or the bedrock was granite itself. Um, One of these interesting pieces of granite was that cliff, that big cliff we looked at the 30-foot pool, which is a picture of it here. It's very prominent in the way that it looks. It's kind of scary looking. Um, but yeah, this is a granitic bedrock and it's very interesting looking. So I tried to kind of draw what that might look like in its layers to the left here. So, typical to granite, you would see something like minerals like hornblende, feldspar, quartz, um, which are all characters of granite. It's also interesting to note that, of course, granite, as we learned through the course, is an intrusive igneous rock, meaning that its source comes from deep within the earth as magma cools and solidifies, sorry. And of course, the rock is more felsic and phaneritic in texture because it has those larger crystals in it. Another interesting thing was the erosion that we saw. And for me, this was most interesting again to look at with this specific cliff here. Because you could really see the erosion in this cliff I found. Um, so first of all, the exposed bedrock tells us that this cliff is eroding. And there's evidence in the way that of erosion. For me, what was really interesting was how I remember in one of our lectures, we talked about an undercut bank. So you can really tell how, first of all, you can tell where the water is mostly eroding it, where you can see how within those like 2 feet of the water is really polishing off the rock there and eroding it to form that undercut bank. Um, yeah, another interesting thing is there's some areas with moss, but then there's some areas without moss, like that more polished area on the bottom, which tells us that change is pretty frequent and erosion is pretty frequent. So this rock had a lot of things to say. Another thing that, of course, you got to mention is the flooding that takes place here all the time. Um, so the most evident thing that you could say and see about the flooding was the time of year that you're going here, right? Like if you're going here in spring, you're going to see higher velocities and more water in the creek because of the snow melt. Or in the fall, you might see some as well because we get a lot of rain in the fall. Um, so that's already kind of made evident, right? That flooding takes place here. If you live here, you would know that. Another thing, though, that I didn't really think of until we were standing on the pipeline bridge is how I remember in our class we talked about how flooding can actually bring nutrients and make the land more fertile, which was, I feel like, really shown in this picture. Um, and so there was a lot of, plants because the river has carried the sediments to them. So I thought that was kind of interesting. But another thing that you can see with flooding too is, if there's debris. So, in this photo, you can also see that there's probably some flooding happening that knocked that tree over there in the middle of the picture. Okay, this one was interesting. The stories of the vegetation. Yeah, the vegetation that was growing there did tell a lot of interesting things about the land. So, for example, here, when we were standing on the floodplain versus the terrace, the terrace is the photo above and the floodplain is down below. Um, they're very different. So on the top, you see more of like the evergreen forest, and on below, you see, the cottonwoods and maples, which indicates actually that the age of the area is different because those evergreens are old. And so on the bottom, you can kind of tell that there's probably been like disturbances within the history because it's got a different forest and the trees are relatively younger. So that was interesting. And then another thing that was interesting was on the vegetation, or sorry, the vegetation that was growing on the bar in the middle of the creek here. Um, so these are another way of telling kind of the changing events that are happening because clearly it's got to be a balance where there's enough support for these trees, which I'm assuming are alder trees because they're a very resilient tree. So there's clearly enough nutrient there for them to be growing, but there's still not enough stability for evergreens to be growing there. So that was an interesting thing that the vegetation was telling us as well. And of course, the suspension bridge. So the erosion was also very evident here. So the erosion has caused this, down cutting motion. And in this, it's likely that the pressure of the water cutting into the riverbed and as sediments were carried downstream, it created this narrow and steep canyon. Um, and so, in other words, the water stream would have eroded the rock under it until it down cut into this steep, beautiful valley that we see. Another thing, though, that I was considering was how there could also be a pre-existing fault zone where it was, because it is very steep. And so it kind of made me wonder if there was like structural weakness within the rock bed itself. Um, I was also kind of thinking about this because when you look at like this creek, it's a pretty straight creek. So I don't know. I don't know if this is the case, but I was, trying to apply my knowledge, and thinking about if there is, a plate there that has shifted or something like this. And yeah, that's kind of a little summary of what I've learned. But if you want to read more, you can read more in my paper, my description. But yeah, I hope that this kind of connected the bits of learnings and what was really interesting to me. So thanks for listening.